All right, so here we're going to be solving absolute value inequalities. Now, with equations, you would make absolute value equations, you would make two equations and solve each of them. So this is going to be it's very similar. All right, so first let's just talk about general concepts. Think about a number that would fit in this spot right here, like the absolute value of what number would be greater than 4. So you could imagine putting a 5 in there, a 6 in there, a 7 in there. That would be true. But you could also put a -5 or a -6, because a -5 inside here would change into a +5, and then that would be greater than 4. Now you can actually put anything right up until you get to 4, right? Because like if you put 4.1 or 4.2, that would be okay. Or -4.1, -4.2, that would be okay. So a graph of the answer for what we have right here looks like this. It starts right after 4 and goes this way, and right after -4, or right before -4, and goes that way. So the answer to this, when does the absolute value of something, when is it greater than 4, is this. It's either when the x value is less than -4 or when the x value is greater than +4. Okay? All right, so let's take a look at the next one. The next one says absolute value of x has to be greater than or equal to 3. So 3 is my first thought. When you put a 3 right here, it would be equal to 3. You could put a 4, or you could put a 5. You could put a -3 or a -4, because that would turn into a +4, and that would be greater than or equal to 3. All right, but you couldn't put a number like 2 here or 0. Okay, so basically what's happening is our answers are starting at 3 and going that way, and then -3 and going this way. So my answer is this. The x value has to be less than or equal to -3, or the x value has to be greater than or equal to +3. So you start to see like a little pattern here. Whenever you have a greater than symbol, you have to think a greater than symbol makes you have an or statement. It's going to make you have a broken answer. Greater than or equal to or statement. Okay? All right, so the next one, absolute value of x is less than 2. So when I start to think of numbers that go in here, I could say 1, 0, -1, and basically everything right up until 2, like 1.9 or so forth, and or -1.9. Okay, so everything right up until 2. So if I graph the answer for this, it doesn't quite get to 2, but it includes everything in here all the way till you get to -2. So that answer is going to be an and statement. So you could write this answer in two ways. You could say that the x value has to be between -2 and +2, or you can also say it like this. You can say that x is bigger than -2, and at the same time x is less than +2. So that way your statement kind of in a way looks like these other ones that we've done before over here, having two pieces. But notice that this means the same thing, but you're putting the word and instead of or, because you want it to be less than 2 and at the same time be greater than -2, so it contains this little area right here. All right, and over here, same thing with 5. Imagine what numbers would go in there. 5 would go in there. 6 would not, 4 would be okay, all the way until -5. So we get an answer that x is between -5 and +5. Or we can say it like this. X is greater than or equal to -5, and at the same time, x is less than or equal to +5. Okay? All right. So, we have a few special cases down below. So let's try to think of some numbers here. So if I put a number like 7 right here, absolute value of 7 is 7. 7 is greater than -6. In fact, any number that I put in there, even if I put like a -4, -4, absolute value would be +4, and that's greater than -6. So anything that you put here is positive. And look at this. You get a positive is greater than a negative. Well, that's true all the time. All right, positives are always bigger than negative. Even 0 is bigger than negative 6. So my answer to this, when I have that the absolute value of something is greater than, or it could be equal to as well, is greater than a negative, I'm going to say always. So my answer is any number I want. My answer is infinite solutions. Or you could say all real numbers. Okay. All right. Here. This next one says that the absolute value of something is less than or equal to -1. So let's try to put some numbers in here. How about like -6? -6 is less than -1, but when you put the absolute value around it, it turns into a +6, and no longer is that less than or equal to -1. Even 0. 0 is not less than or equal to -1. If I put a +5 in here, that's not less than or equal to -1. So you know what? This has no solution at all. So if it's no solution, that means you leave the graph blank and you say no solution. A positive cannot be less than a negative. All right, over here, we want with the 0, everything is less than or equal to 0. So let's see. If I put a 0 here, that seems to be okay. But any other number, if you put a 1 right there, 1 is not less than or equal to 0. Absolute value of 4 is not. -5 is less than or equal to 0, but because a -5 would have absolute value bars around it, it would change to a +5 and then become false. All right, so the only number that seems to work here is 0 itself. And frankly, the only reason that works is because it has a little equal bar right there. So 0 is my only answer. Okay. All right. Let's see. Absolute value of x is greater than 0. So let's see. I would say let's try putting like a -6 in there. So if I put a -6, it's going to be +6 is greater than 0. That seems fine. -1 could turn into a 1. That's greater than 0. Now 0 itself would not work. So that's going to be a no. But anything after that, put a 1, a 2, a 3 here, everything's going to be fine. So this answer is looking a little bit strange. It's basically not 0, but everything after and everything before. Now, if this had an equal bar, then I would also include this spot here, but it does not. So you just have to decide. So what I end up getting is this. I get x's less than 0 or x's greater than 0. That would be my solutions. Okay, so we're going to turn this into when we have to basically solve equations with inequalities with absolute value, right? So we're solving inequalities that have more to them. So what's going to happen to us is this. We're going to basically think of this. When I see a less than, that's an and situation. Less than is and I like to say this like less than, and so then you could say, oh, less than is and greater, you can change it to greater. So greater is or greater. I know it's not how it's spelled, but you can kind of think of that little trick in your head. All right, so either way, we're going to start off the same way. We have the absolute value of x plus 2 is greater than or equal to 4. So basically what we're going to do is we're going to take whatever's in the absolute value bars. This is nice and clean. There's nothing on the outside like there is over here. Okay, so we're going to take x plus 2 and we say that that is greater than or equal to 4. So we basically leave everything like it is without the bars. And this is a greater than, so then we write the word or, and you'll see it in the answer in the graph. And we put x plus 2 and we change it, we flip it to a negative just like we did earlier in the equations, but we also change the symbol. Okay, so basically we're kind of like doing what we did right here. You can kind of see it, it's a little bit backwards, but this is the first one and then this is the second one. So that's kind of like what we're doing right here and right here. Okay, so let's solve it. Take away 2, so I get x is greater than or equal to 2. Now when I take away 2 over here, I get x is less than or equal to -6. So look at this graph. It's an or, it's going to be broken. So greater than or equal to 2 would put me that way. Less than or equal to -6 would put me this way. So I don't have to worry about the word because the graph will make me know it's an or situation. So my answer is x is greater than or equal to 2 or x is less than or equal to negative 6. Anything in that category, in one of those two categories, is going to make this original problem true. All right, so for the second problem, we have to clean this up. Now this looks like a less than problem, but let's clean it up. So I cannot do 2 minus 5. I have to take away 2. Then it's negative 5, which is trying to multiply by x minus 1. And this is negative 10 now. Now to get rid of multiplication, I use division. So divide by negative 5. When I divide by a negative, well, the symbol flips over and I get a 2. All right, so actually this is a greater than situation. This is an or situation. So I get x minus 1 is greater than 2, or x minus 1 is less than negative 2. So I leave the x minus 1 alone. That never changes. It's the symbol and the number afterwards. So if I add 1 here, I get x is greater than 3. Or if I add 1 here, I get x is less than negative 1. So you're going to see greater than 3, less than negative 1. So it's always broken. All right, over here, let's clean this up. I add 4 to both sides. So I have 2x minus 1 is less than or equal to 13. Oops, absolute value bars. Okay, so same thing as before, but this is a less than situation, so it's going to need the word and. So 2x minus 1 is less than or equal to 13, and 2x minus 1 is greater than or equal to negative 13. So the same thing we did earlier, except the word in the middle is changing. Now, if you don't want to write the word, you can write it at the end, but I'm going to solve this both. So if I add 1 to this, I get 2x is less than or equal to 14. And divide by 2, I get less than or equal to 7. Add 1 here, I get 2x is greater than or equal to negative 12. And divide by 2, I get greater than or equal to negative 6. So look at the graph. Less than or equal to 7 goes that way. Greater than or equal to negative 6 goes this way. Oh, they meet. So actually you get one connected line. So you can either write this as x is less than or equal to 7 and x is greater than or equal to negative 6. Or if you wanted to, you could note, now that you notice it's connected, you can say, oh, x is between negative 6 and 7. So you can write your answers either way. You can write it in this big statement, or you can write it a statement like this. Okay, so we have a couple special cases here to finish off. If I take away 8 from both sides to clean this up, I get x minus 6, absolute value is greater than negative 7. Okay, so remember, this part in here, this is going to produce a positive thing. So you need to stop. Whenever there's a negative on the other side of an absolute value, equation, or inequality, you got to stop. All right, so you stop and you ask yourself, what's going on here? It's not supposed to be negative. So then you say to yourself, when is a positive greater than a negative? So a positive is greater than a negative all the time. Every single moment it's going to be greater. Even if it's 0, it's still bigger than a negative. So my answer here is infinite solutions, or all real numbers. So my answer is anything I want it to be, anything. Okay, so let's do this one more here. I add 6 to clean this up, and I get absolute value of x plus 5 is greater than, let's see, negative 4. Oops, and I made a mistake. I meant for the symbol here to be a less than. I wanted that to be a less than because I don't want it to be the exact same thing as the last problem. So I meant that to be a less than, so let me change it here. Okay, so now let's talk about this. So this is asking you, when is the absolute value of something less than a negative? Now, the absolute value of something is always a positive. I mean, I guess it could be 0 as well, but when is a positive or 0 going to be less than a negative number? It's never. It's always bigger, right? So you ask yourself again, you stop and you say a positive is less than a negative. And you say to yourself, oh, well, that's never going to be true. And again, I stopped because I had a negative here and I didn't know what to think of that. So a positive is never less than a negative. So that's my answer is no solution ever. And this is going to be blank over here. You're going to leave this blank and you're going to write the words no solution. Okay, and that's that. Bye-bye.